6.2, Law of Cosines. How do you use trig to solve and find areas of oblique triangles? So it's the same question that we had in 6.1. This time we're using the law of cosines, or learning the law of cosines. We'll still be incorporating the law of sines. So we learned that we can use the law of sines when we have either angle, side, angle, 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 side, or side, side, angle. And remember, this one we had to be careful because of the ambiguous case. Today we're going to look at triangles that are side, 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 or side, angle, side. And for those cases, we use the law of cosines. These are the two formulas. They're actually the exact same formula, just written differently. The first one is really how I think of the law of cosines always. I never memorize the second one. And you can manipulate the first one to get the second one. If you think about, what did they do? If you add, I'll use this. If you add negative 2bc cosine A to both sides, okay, so move that over to this side, and you subtract a squared from this side, that's where you're going to get your b squared minus, or plus c squared minus a squared. Then you can divide by 2bc, and that's where they get this. And it really just depends on what you're trying to find. Are you trying to find an angle, or are you trying to find a side? If you're trying to find an angle, you're going to want to use the second one. And if you're trying to find a side, you're going to want to use the first one. Or just always use the first one like me. Doesn't matter. Example 1. Side, side, side. Given triangle ABC, side A, so maybe I'll draw a picture, label my picture, A, B, C. Side A is the side across from angle A, is 10 feet. Side B is the side across from angle B, is 6 feet. And side C is 9 feet. Find the measures of angle A, B, and C. So I'm going to find the measure of angle A first. So I'm going to write cosine of angle A equals B squared plus C squared minus A squared divided by 2, I already forgot, BC. 2 times 6 times 9. Cosine of A equals, and now I'm going to use my calculator. I'm just going to do 6 squared plus 9 squared minus 10 squared. And 2 times 6 times 9. To get A alone, I'm going to do inverse cosine. Oh, it's a good time to check to make sure you are in degrees, because you want to be in degrees. And we get 80.9 degrees. Now, once we've found one angle, we have a choice. We can either use the law of cosines again, or we could use the law of sines. If we use the law of sines, though, this is where you have to keep in mind, okay, so if I'm using this angle and this side, and I'm trying to find this angle, this side, this is a case of SSA or ASS, and that could be the ambiguous case. You want to be careful. So I usually like to stick to the law of cosines, then I don't have to worry about the ambiguous case. I'm going to do the cosine of B is equal to, now I'm going to use the other two sides, so 9 squared plus 10 squared minus 6 squared, all divided by 2 times 9 times 10. And now I'm going to do the inverse cosine of 145 divided by 180. And I get angle B equals 36. Am I not in pen? Angle B equals 36.3 degrees. Now, once you know two of the angles in a triangle, you know that all the angles add up to be 180, and so you can find the third angle without any trig. Okay, a bridge is supported by triangular braces. If if the sides of each brace have lengths 63 feet, 46 feet, and 40 feet, find the measure of the angle opposite the 46-foot side. So we want this angle, so we can just call that angle A. Cosine of angle A equals, now I'm going to take the sum of the two sides right next to angle A, the sum of the squares, and then I'm going to subtract the square that's across from that angle. And then 2 times 63 times 40. And then I'll use inverse cosine again. So both of those examples are situations where you have side, side, side. All right, let's look at this example. This is an example of side angle side. During a hockey game, Crosby and Kane skate apart with an angle of 15 degrees between them. Crosby skates for 5 meters, and Kane skates for 7. How far are they apart? So since I'm looking for a side, I'm going to use the other form of the law of cosines. And that says x squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 15. And then just remember your order of operations. You're multiplying all of these before you're subtracting. A common mistake I've seen students do is to do this out of order. So I'm going to do the exponents first. So I get 25 plus 49. And then I'm going to do all of that at the same time. So, 2 times 5 times 7 times cosine of 15. And now I can add the numbers 45 plus 49 minus 67.6. To find the distance between the two hockey players, we're going to take the square root. And we get 2.53 meters. And it would make sense that that distance is not too big because the angle between them is so small, just a 15-degree angle. All right, let's look at another example. 2 helicopters are dispatched from a ranger station to look at some lost hikers in a national park. One helicopter departs the station I see that there's bearings involved, so I'm just going ahead and drawing my compass. Departs the station at north 35 degrees west. So this is north, this is west, so this angle right here would be 35 degrees. Traveling 100 miles per hour. The other departs at north 27 degrees, so here's east. Traveling at 80 miles per hour. This one's 100 miles per hour. After 15 minutes, the pilots need to know the distance between them to report, or the distance, between them to report back to the station. Figure out the distance between the helicopters after 15 minutes. So I believe what we're looking for is this distance right here. And we are given some information so that we can find this distance. So it's 80 miles per hour, so I'm going to do 80 times, and then it's how much of an hour. So it's 15 minutes out of an hour, 15 out of 60 minutes. So this distance here would be 20 miles. And we'll do a similar thing over here. We got 100 miles per hour, but we're just going 15 out of 60 minutes, and so that's 25 miles. So now we have those distances, and we can add these two angles together to find out the whole angle, 62. And then now we're ready to set up our law of cosines. So I'm going to do x squared equals 25 squared plus 20 squared minus 2 times 25 times 20 times the cosine of 62 degrees. And I can really do 25 squared plus 20 squared at the same time to save a little bit of time. And then do all of that together, 2 times 5 times 20 times cosine of 62. And then subtract the 2. And then to get x alone, we take the square root. The distance between the two helicopters is 30.5 miles. Here's another one involving bearings. I'm not going to do this one, but if you want an extra practice, you could pause the video right now and give it a try. All right, lastly, we're going to look at finding the area of an oblique triangle. And this is if we're given side, side, side. The law of cosines can be used to establish the following formula for the area of the triangle. So you first are going to find S, and S is all the sides added together divided by 2. And then you're going to multiply S times S minus each of the 3 sides multiplied together, and then take the square root. Let's try it out. So here's an example of an oblique triangle. We're supposed to find the area. So I'm going to first find S. I'm going to do 8 plus 41 plus 44 and divide it by 2. $46.5. So then we're going to take the square root, and we're going to do 46.5 times, and we're going to subtract each of the sides from S. So I'm going to start with the smaller one, 46.5 minus 8. 38.5. Okay, then I'm going to do 46.5 minus 41. 5.5. And then I'm going to do 46.5 minus 44. And I get 2.5. And now I'm going to take the square root, and multiply all of these numbers together. So the area of this triangle is 156.9. All right, thanks for watching.